The first fundamental theorem of calculus states, if a function f is continuous on the closed interval a to b, and f is the antiderivative of f on the interval a to b, then the integral from a to b of f of x dx equals the antiderivative of b minus the antiderivative of a. That's so ugly. What? There are two steps when using the first fundamental theorem of calculus that you must do. First, you need to write the definite integral is equal to the antiderivative evaluated at a and b. So you need to write this. A to b f dx equals the antiderivative from a to b. And then step 2, you need to evaluate at, the antiderivative at a and b. Pro tip, you always need to write this. We're going to evaluate the integral from 0 to pi over 4 of secant squared x dx. So what should we do first? We need to write that this integral equals the antiderivative evaluated from a to b. Alright, so we're going to use some handy-dandy calculus skills and know that the antiderivative of secant squared is just tangent. And now we're evaluating it from 0 to pi over 4. Okay, so tangent of pi over 4 minus tangent of 0 gives us 1 minus 0. And what does that equal? 1. The second fundamental theorem states that if f is continuous on an open interval I containing a, then for every x in the interval, the derivative of the integral from a to x of ft dt equals just the function. Amazing. There are 3 steps in using the second fundamental theorem of calculus. Step 1, evaluate at the upper limit and then multiply by the derivative of the upper limit. Oh no, my handwriting is getting jank. Hope you can read that. 2, you're going to evaluate at the lower limit. And then, guess what? Multiply by the derivative of the lower limit. That is insane. The third step, you just subtract. How amazing. I'm about to show you an example of the second fundamental theorem of calculus. It's actually really simple, it just looks kind of difficult. So, we're going to say that y equals the integral of 0 to x of the square root of 1 plus t squared dt. Okay, so what you want to do is you want to plug this in for your t values, right? So when you plug it in by the t values, you're going to get the square root of 1 plus x squared, and you do not take the antiderivative of this, but you just multiply it by the derivative of x. So the square root of 1 plus x squared times the derivative of x, 1, is just this. Crazy. Since the last example was so difficult, I thought I'd show you all another one, just so you get a clear understanding. So, we're plugging in 2x into cosine t, right? So cosine 2x. Wait, we're not done though. What is the derivative of 2x? It's 2. Boom, there's our answer. Amazing how math works. We're geniuses. I would like to thank everyone for taking the time to watch this video, especially you, Miss Jensen. I hope that I can really help you understand the first and second fundamental theorem of calculus. I'm glad you took the time to watch it. Just thank you.